Now let's discuss about the position of a point with respect to a parabola. Let's say a parabola has been given to you. So a point can be either inside this parabola, a point can be either on the parabola, or a point can be outside the parabola. Right? There are only 3 points that are possible. So how can we find out whether the point is lying either inside, on, or outside the parabola? So I hope you all remember we had studied in straight lines. If let's say this is our equation of parabola, we can write this as S is equal to y square minus 4ax. And if I was to find out S1 on a point x1 comma y1, then this would be written as y1 square minus 4ax1. We had studied a part of this while we were doing circles as well, to how we can find out S1. We had studied how we can find out T as well there. So similarly, S1. Once we know the points, we can find out S1. Once we know the value of the coordinates of the point, we can find out S1. And now, once we've found out S1, there can be 3 possible values of S1. It can either be less than, greater than, or equal to 0. So let's say if the point is inside the parabola, then our S1 would be less than 0. If the point is lying on the parabola, then our S1 would be equal to 0. And if our point is lying outside, then our S1 would be greater than 0. Again, not a very new concept. This thing we had studied in circle as well. So just a reminder. Again, the same thing has been mentioned here as well. You can look at it. y1 square minus 4ax1. We referred this to as S1, where what we are saying that S is equal to y square minus 4ax. Now, let me teach you about the position of a line or any other conic with respect to a parabola. Now it is not necessary that it needs to be a parabola only. It will work for ellipse and hyperbola as well, the same concept. So remember it here only. Let's say the equation of a line has been provided to you, which is y is equals to mx plus c. And I have been provided with our conic, which is y square is equals to 4ax. And if I was to check the position of this line with respect to this conic. So what are the possibilities that can happen? Firstly, if this is my parabola, the line may either cut the parabola, either at 1 point or 2 points it may intersect, or the line might become a tangent to this parabola, or the line might not touch the parabola at all. So these are the 3 possibilities. So how can we find out? From this equation of our line, we will take up any one variable, which is x or y. Here y has been already provided, which is mx plus c. We substitute it here, and then we would get a quadratic in the form of x. Let's say that quadratic is ax square plus bx plus c. Let us assume. Then we need to find out the discriminant, again, which is b square minus 4ac. And once we found out the discriminant, if d is greater than 0, line cuts the parabola. If d is equal to 0, line is tangent. And if d is less than 0, line is not touching or intersecting. Again, an important concept for you to remember. A very important concept, in fact. So this was about a line. Now let's say if instead of a line, you were given another conic. Let's say a parabola is only given. y square is equals to 4ax is our standard parabola, and let's say another parabola is given, which is x square is equals to 4a y plus k. Let's say this is another parabola which is given. So from here again, since you can see y is the single degree term here, you take out the value of y, which would be x square minus k upon 4a. Then you substitute this value in this equation. Again you would get a quadratic, of course, or a biquadratic, and then you take out the determinant, and again the same concepts would apply. If d is greater than 0, the parabola or the other conic would cut or intersect at one or more points with our parabola. If it is equal to 0, it is just a tangent, it is touching it at one point, and if it is less than 0, it is not touching nor intersecting. So important concept must be remembered. Now let's study about the equation of chords. Let's say a parabola has been given to you. Any line which passes through the parabola and intersects it at 2 points is our chord. We have already studied that. We've already studied about double ordinates as well, latus rectum as well. So now this is nothing much. Let's say it intersects the parabola at 2 points. One is P1, which is x1 comma y1, and the other one is P2, x2 comma y2. Now if I were to find out the equation of this chord, what are the ways I can do that? Firstly, I would be required to find out the slope of this line. Simply, I have been provided with 2 points. Now using these 2 points, I can find out the equation of any line. We have studied this in straight line. So first I'll find out the slope, which would be y2 minus y1 upon x2 minus x1. And now how can I write the equation of any line when we know the slope and we know any one point? It is x minus x1 is equals to m, which is y2 minus y1 upon x2 minus x1 into y minus y1. I'm sorry, this would be y minus y1 is equals to y2 minus y1 upon x2 minus x1, x minus x1. This is our equation of the chord. Now, what are the other things about this chord that we can make out? First, we know that point P1 and point P2 both lie on the parabola. So if I try to eliminate at least two variables from this equation, which is, let's say, x2 and y2, because I have 4 variables currently in this equation. If I were to eliminate 2, so the property that I can use here is that both points lie on the parabola, which means they would satisfy the equation of our parabola as well, which is, let's say, y square is equal to 4ax. So if, let's say, the 2 points are lying on the parabola, they are satisfying its equation, then let us use the parametric form here. It would become much easier for us. Instead of 4 variables, we would then have just 2 variables. So if we are using the parametric form, then we can say that point P1 would become a t1 square comma 2a t1, and point P2 can be written as a t2 square comma 2a t2. Now if you see, if I was to write down the equation of chord using this format only, now I use these 2 coordinates, then you know that we would have only 2 variables, which is t1 and t2. So we would be required to have 2 other equations so that we can find out what exactly are the points and we can find out the exact equation of chords. So that is what we are trying to find out here. So if I was to write down the equation now of our chord using these 2 points, it is written in this format. After, again, we use this format only, y minus y1 is equals to y2 minus y1, and instead of y2 we are using let's say 2a t2, and instead of y1 we are using 2a t1. After substituting these values and simplifying it further, we get this to be our equation of the chord, which is y into t1 plus t2, which is equal to twice of x plus a t1 t2. So this is our equation of the chord. Now, what are the other things that we can find out about this chord? See, we know this is our chord. Now, one thing that we can assume is, let's say this chord is passing through the focus, which is a comma 0. Now, this need not be the latest rectum, but it can still pass through the focus. So we call this chord as the focal chord. Again, latest rectum is also a type of a focal chord, but since it is a double ordinate, so we call it latest rectum. Else any other line which is at any other angle apart from 90 degree and it passes through the focus and it is a chord, so we call it a focal chord. Now, if I was to say that this line passes through the focus as well, that means this entire equation of our line would satisfy this point as well, a comma 0. If I put a comma 0 as x and y in this equation, it would satisfy. So after satisfying this, what is the extra thing that we get is t1 into t2 is equal to -1. Only for focal chord. So this is an extra information that we found out about a focal chord. That is exactly what is mentioned here. The condition for the chord of a parabola to be a focal chord is t1 into t2 equals to -1, where t1, t2 are parameters of point, considering this p1 and this to be p2, at1 square, 2at1 and at2 square, 2at2 on the parabola. So now, till now, what have we found out? Let's say if this is our standard parabola, which is y square is equals to 4ax, and this is our focus, and a chord is passing through this p1. We know the coordinates of p1 in the form of parameters. We know the coordinates of p2. F is known to us. Now, what are the things that we know about this line, this focal chord here? First of all, we know that this line contains 3 points, which is p1, p2 and f. So these 3 points will always satisfy the equation of this line. Secondly, since we know p1 and p2 are in the form of parameters, which is t1 and t2, so we know one more relation between them, t1 and t2 is always equal to -1. And apart from that, what else can we find out? That this is a chord of this parabola. So if you remember, if I put the equation of this line into the equation of this parabola and I form a quadratic, and then I find out the discriminant, it will always be greater than 0 because it is cutting the line at two different points. Now, one more thing that we need to remember is the length of this focal chord. How can I find out the length of this focal chord? Now, it is very easy. Since you know what P1 is, you know what P2 is, you have a relation. You can use distance formula and find out the length of focal chord. And that has been already found out here to be A into T1 minus T2 whole square. Length, this is the length of our focal chord. So we now also know the length of our focal chord. If you were to try to satisfy, let's say you have 2 points, and if you were to find out the distance formula between them using this formula, x1 minus x2 whole square, which is a t1 square minus a t2 square whole square, plus y2 minus y1, which is 2a t1 minus 2a t2 whole square, then the length that you would get is this one. And again, upon simplifying this equation, the condition that has been used is t1 into t2 is equal to -1, since this is a focal chord. So that is all for the theory of this chapter. Again, earlier there used to be a lot of things that we had to study about: tangents, normals, their equation, how they perform, etc, etc. However, now those things are not there. The only one more thing that you need to remember, we have already studied this in circles as well. One is chord of contact. Chord of contact. I hope you all remember we had studied this in circle. Let's say if a parabola has been given to you, and from a point, let's say from this point, there are two tangents drawn. One is this tangent and the other one is this tangent. Now the point at which the tangent intersects the parabola if we join this line, this is our chord of contact. So how can we find out the equation of chord of contact? When the outside point has been given, p x1 comma y1, simply we write down its equation as t equals to 0. And I hope you all remember we had studied in circle as well as straight line how we can write down t. Let's say if y square is equals to 4ax has been given to you, so t would become y1 would be equal to 4a x plus x1 by 2. This is how t is generally written. So we can write this as minus 4a x plus x1 by 2, and this would be equal to 0. Once we solve this equation, this would become our equation of the chord of contact. And now let's say if in any question a parabola has been provided to you, a chord is given, let's say the midpoint of the chord is given. Midpoint of the chord is given to you x1 comma y1. So how can you write down the equation of this chord? By just the midpoint. The formula is t is equals to s1. And t, you know how you can find out, and s1 is again very easy for you to find out. So t equals to s1 would give us the equation of this line, if and only if the midpoint of the chord is given. Now this midpoint is the distance, which means this distance and this distance are equal. So I hope you all remember all these concepts we had studied in circle. The same thing applies here in parabola as well. Now using this, we will be solving the previous year JEE main questions.